My dear children, today I came to explain you the hybridization of carbon atom. Hybridization of carbon atom. So hybridization is I think new word for you. But think about, I think you know about the word hybrid. Hybrid in everywhere related with animals and flowers and fishes, right? Hybridization. It is the mixing of characters, mixing of two or more than two characters, hybridization. Elements also undergo for the hybridization before the formation of compounds, right? Today I am going to explain you about the hybridization of carbon atom, right? Then, so I think you have a question. I explained my third video. Carbon forms four covalent bonds. Four covalent bonds. So, how it becomes? Carbon has 4 electrons around carbon atom. But from where these 4 electrons? So it is a problem, no? Then today I explain that problem. Then shall we come from carbon? Starting from the electronic configuration. C6 atomic number, 1s2, 2s2, 2p2. The second energy level, 2s2. You know that orbitals are having shapes. What is the shape of the s orbital? Spherical. So it is a spherical orbital. It has 2 electrons. It has field. This is the method of representation. Then p orbitals, you know that there are 3 p orbitals. What is the shape of p orbital? I'll draw here. This is the shape of p orbital. What do you call? Dumbbell shape. Dumbbell shape. So 2 electrons. One electron in each. Right? Dumbbell shape. How many p orbitals in the p sub-energy level? There are 3 dumbbell shaped p orbitals at the p sub-energy level. 3 dumbbell shaped. These are the dumbbell shape. Then I draw here. These are the dumbbell shape 3 p orbitals. Each has, not each, only 2 has sp2. This one has 1 electron. Other one also having 1 electron. That one orbital can exist 2 electrons. It is the rule. I think you know all the details about that. Then these are the 2p sub-energy dumbbell shape 3 orbitals. Then there's a problem, no? You know that these 3 orbitals are not lie as I had drawn, how they exist. See here. This is x-axis, y-axis, z-axis. These three axes are perpendicular to each other. Perpendicular to each other. Right? Then x and y perpendicular, z perpendicular to x, y perpendicular to z. These are the three axes. Three axes come together to form the 3D nature, 3D structure. Then you know that we can explain these three orbitals as px, py, pz. This is pz. Why? This orbital lies along the x orbital. This orbital lies along the y orbital. Y axis really. This orbital lies z axis along the z axis. Then these three dumbbell shaped p orbitals exist perpendicular to each other in the three axes x, y and z. You must know that. But for the easiness, we can draw like this. Is it clear? Right. Then, if I draw these three p orbitals like px, py and pz, then two electrons all together at the p sub energy levels. You know that the filling order, one electron fills in the first one orbital, other electron fills in the other orbital. So there's an empty p orbital. This is the orbital diagram of carbon considering the second energy level. I think, is it clear for you? Right? That existence is the normal method, normally existed, normally present method of the carbon atom. It is explained as the ground state. Ground state. So that normal configuration is the ground state configuration of carbon. So generally we are giving the normal configuration, all are at the ground state. Right? Then, so it is clear that now according to that structure, how many bonds can be formed? Here, no space. It is filled, unable to form compounds or bonds. But sharing ability has only this orbital and this orbital. Out of the three p orbitals, the sharing ability is having only two, because one in each. When hydrogen comes here to share, can be share here, because the maximum amount of electrons can be existed in an orbital is 2. Then now you are clear that carbon is unable to form a compound or covalent, 4 covalent bonds, it can be formed only 2 shares. Is it clear, my dear children? Then, if it undergoes the formation of, according to this structure, it can form one hydrogen here gives one electron from hydrogen. Carbon combines with 2 H atoms, CH2. But how many electrons at the outermost orbital? 2, 2, 2. From the electrons of the hydrogen also. Only 6. Not completed the octet. The compounds do not form by this method by the carbon. Right? So I show you at the ground state, keeping this configuration, carbon is unable to form a compound. Right? Okay. Then carbon becomes excited state. Arrangement for the formation of compound. If carbon atoms come around carbon, hydrogen atoms come around carbon, it gets arranged to form the compound. So first it becomes excited state. So as the excitement, that one electron of the s orbital transfer to the empty p orbital. Here 2s orbital has 2 electrons. Out of these 2, 1 electron transfers to the empty px orbital. This is the excitement. Right? Now, after the transference of this electron to the pz orbital, now what is the configuration? This one has only 1 electron, 2s1, 2p. These are the dumbbell shaped orbitals. This one has 1. These are the 2 electrons who are present. Now, this also having 1 electron. After the excitement, see here. Now, carbon has 4 electrons in 4 orbitals, 1 in each. So, then it has the ability to form 4 bonds. 1 hydrogen comes here, giving electron. Other 3 H atoms also can be combined these 3 orbitals, forming how many shares? 1, 2, 3, 4. Okay? So, after the excitement, it becomes 2s1, 2p3 configuration. 2s2, 2p2 becomes, after the excitement, 2s1, 2p3. Right? Then, now, is it okay? Now carbon is able to form covalent bonds. Now hydrogen can participate or share the electrons with carbon easily. No. There's a other problem also. Right? But free orbitals, 4 orbitals are present, but there is a problem. for the combination, then I like to think about, right, the pollination between flowers. You have done in O level, I think. During the pollination, so flowers are shown adaptations to avoid the self-pollination. They always try to do the pollination between other flowers, right? Given the so many adjustments, right? Presentation of the petals, fragrance, etc. Similarly, here also there is a problem. S orbital has spherical shape. These three orbitals are having dumbbell shape. Then it is difficult to form covalent bonds with hydrogen. Then, after the excitement, it becomes two arrangements. The two problems, do you remember? 2s orbital, 2p orbitals. They are having energy difference, little energy difference, right? 2s, the 2p has little greater the 2s. Therefore, that energy difference should be finished, right? To be covered up. Then other one is two shapes, dumbbell shape. If electron can exist here or here or at anywhere of this orbital, so it is very difficult to find out the coming hydrogen, where the electron, how to participate to form the chair. These are the problems. Then, to avoid these two problems, first s orbital and 3p orbitals come to the same energy level. Now no energy difference, right? Then the other problem is having the two shapes. Now shape also come to the same shape. Thus avoid these two problems. This is the hybridization. This is the hybridization. Then after the excitement, it should be undergone for the hybridization. During the hybridization, what should be done? Energy difference should be covered up. Energy difference. They come to same energy level. Other one is the two shapes, spherical, dumbbell. These two shapes become one shape. Right? This is the hybridization. I'll explain that process using a diagram, energy diagram. It is easy. So this is the energy. Here 2s, spherical orbital, 2p high energy level, little high energy level, both at the second energy level, principal energy level. Then 2p, there are three dumbbell shaped orbitals like this. What is the state? Ground state. Ground state. Configuration 2s2. 2 electrons here. 2p3, 2p2. 2 electrons. 1, 2. There's the energy difference. Be the ground state. Then it comes to the excited state. This electron transfers to the empty p orbital. Now 3p orbitals all are having 1 electron in each. But s orbital has only 1 electron. This is the excited state. Now the configuration becomes 2s1, 2p, 3. Number of electrons does not change. 4 electrons, here also 4 electrons. only change the place, excitement. Then after that, come to the hybridization state. Hybridization state. Then, so it is easy. These 3 orbitals come down little, releasing energy. Right? Then this orbital goes up, gaining this amount of energy. So they come to the common energy level, thus common energy level. Right? To transist downwards, they remove energy. To transist upwards, this electron gains the removal energy of p orbitals. Right? Then they come to the common energy level. Now shape also become common shape. No dumbbell. The one lobe reduces. Only remains one lobe. This the reduced lobe. These are the shapes of the new shapes of the so formed orbitals. Then there are 4 orbitals. 3 orbitals combined with 1 s orbital. Then electron, all I have in the as 1 electron in each. This is the method of hybridization. See here, ground state. 2s, 2, 2p2. Dumbbell shape, spherical shape, 2 energy levels. Excited state happens transference of 1 electron to the empty orbital. After that, hybridization. Hybridization state, after the hybridized, all the three orbitals come down, releasing energy. S orbital goes up, gaining energy. Now, all of them come to the same energy level with the same shape. Now, this is the S orbital. These are the 3p orbitals. 3p orbitals. Now, all four are hybridized orbitals. There are, you have to study other types of hybridizations. I'll do again in my other videos. Today, I am going to explain this type of hybridization only. Then here is one s orbital. That s orbital combines with 3p orbitals. So spp, sp3, this is the type of hybridization. Then this type of hybridization is explained as sp3 hybridization. So is it clear that? Then after the hybridization, it is clear that these are the hybridized four orbitals. All of they are having, all the p orbitals, sp3 orbitals are having same energy, same shape, same energy, same shape. This is the meaning of the hybridization. Right? Now, all the H atoms come to form covalent bonds with carbon. 8 atoms, 4 8 atoms come here. All of they are having same ability because they are identical 4 orbitals. No competition among 8 atoms because all are same. Right? This is the arrangement. sp3, 4 orbitals. 1, 2, 3, 4. This is the arrangement. Then all are identical. All are identical. All the angles are same. All the angles are same. This is the arrangement. This arrangement is explained as tetrahedral arrangement. Tetrahedral arrangement. Okay? So, after the sp3 hybridization, sp3 hybridized 4 orbitals are arranged around the nucleus of carbon to give the tetrahedral arrangement. Giving the tetrahedral arrangement. Why it is tetrahedral? Do you know that? Hedral means four faces. See here, one face, other face. Similarly, around 3 faces, 3 triangular faces. Base, other triangular face. 4 triangular faces all together. This is the tetra, means 4 hedral faces. Tetrahedral arrangement. So, after the hybridization, they give tetrahedral arrangement. Is it clear? Then when H atoms comes here, then like bees come to the flower, they see all are identical. If 4 bees come, no competition because all are same. Then one by one joins with these 4 orbitals with electron forming 4 covalent bonds. Forming 4 covalent bonds. Right? Then these are the orbital joins with hydrogen becomes a covalent bond. Right? Then how many covalent bonds are formed? 4. 1, 2, 3, 4 with H atoms. Right? Each atom has 1 electron with the spherical orbital. Then now a molecule is formed. Molecule also having tetrahedral shape. Molecule also having tetrahedral shape. After the formation of molecules, these are become covalent bonds. Then all the covalent bonds are identical. All are identical. These angles are same. All the angles are same. There are 4 angles, 109.5. 109.5. I'll draw here 1 orbital, 1 covalent bond, right? Then this is the carbon atom. This is sp3 hybridized orbital. It has an electron. When hydrogen comes here, like this is the nucleus of hydrogen. The electron of hydrogen share with the hybridized electron of carbon, forming a shared electron pair. This is 1s orbital of hydrogen. 1s orbital of hydrogen. This is the sp3 hybridized orbital of carbon. Similarly, 4 bonds are formed similar to this. Then, if we consider the axis, this is the 109.5 angle. 109.5 angle. Right? So the whole molecule is tetrahedral. The formula is CH4. Right? So, do you have the problems? I think no problems because hydrogen, there's a problem, I think. Carbon undergoes hybridization. Arrangement, excitement, follow the hybridization. Because the carbon atom has not the proper arrangement, suitable arrangement to form the covalent bonds. Right? But hydrogen has only 1 electron with the s orbital. Not need to give any arrangement. Then you must know that hydrogen never undergoes hybridization. But all the other atoms undergoes some type of hybridization we will study later. Right? Carbon also having other types of hybridizations during the formation of different compounds, right? So this is the simplest form of hybridization. It is the sp3 hybridization. Today I explain you what is the hybridization, how it was happen, how it is happen of carbon atom, and explaining with the formation of a molecule also. Right? Then I hope to come with in future by other videos to explain you what are the other type of hybridizations of carbon, and after the formation of, it is clear that the shapes are also different, get different each other, right? So today I will stop the video. I had explained you. Then I hope to meet you by my next video. Thanks, my dear children.